Fresh, yo. Touch is mad if being sure.
Building multi-step applications and AI workflows shouldn't mean writing custom, complex code. Developers often spend too much time tracking progress, writing error handling logic, and managing retries instead of focusing on their innovation. AWS Lambda Durable Functions simplifies all of this. Write code using your programming language and IDE, while Durable Functions provides built-in patterns to manage progress and error handling. Build multi-step applications and AI workflows faster with Lambda Durable Functions without having to write complex logic or manage additional infrastructure. Get started
to the worldview they subscribe to. It's really about regulating other people's speech.
Yeah.
Like people
There's
are like,
an implied,
you know, when like in the debates about what showed up in the Facebook, I think what people mostly want is they want a model that has been RLHDF'd to the worldview they subscribe to. It's really about regulating other people's speech.
Yeah.
Like people are
there's
like,
an implied,
you know, when like in the debates about what showed up in the Facebook feed, I having listened to a lot of people talk about that, everyone is like, well, it doesn't matter what's in my feed because I won't be radicalized. I can handle anything. But I really worry about what Facebook shows you. Feed. I having listened to a lot of people
through some of the measures that will be put in place and what they will mean for people and companies in the EU.
The EU will divide AI applications into 4 risk classes. Some of them will be completely forbidden, like facial recognition on a mass scale. There's
through some of the measures that will be put in place and what they will mean for people and companies in the EU.
The EU will do some exemptions for military and law enforcement, and also behavioral control and the control of your thoughts. That will be also banned. But high-risk applications, for example, some exemptions for military and law enforcement, and also behavioral self-driving cars will be allowed in the EU, but they have to be certified. The technique has to be open so that everybody can see how that works. And normal, I would call it like ChatGPT on a medium risk level, that can be in the EU without any restrictions, but it has to be documented how this thing works, and everybody has to know that he is dealing with AI, that he's not talking to a human. This is one of the essential measures in the whole legislations. You as a consumer shall always decide, do I want to talk to a machine? I have to know that it's not human. This is the basic principle, but there are also some AI applications that will be not regulated. For example, audio and video altering programs that make these well-known deep fakes. These are not regulated. They don't pose a high risk in the view of the EU.
Is there a kill switch? A way to shut the whole thing down?
Yes. What really happens is like any engineer can just say like, we're going to disable this for now, or we're going to deploy this new version of the model.
A human?
Yeah.
The model itself, can it take the place of that human? Could it become more powerful than that human?
So in the sci-fi movies, yes. In our world, in the way we're doing things, this model is, you know, it's sitting on a server. It waits until someone gives it an input.
But you raise an important point, which is the humans who are in control of the machine right now also have a huge amount of power.
We do worry a lot about authoritarian governments developing this.
Putin has himself said whoever wins this artificial intelligence race is essentially the controller of humankind. Do you agree with that?
So that was a chilling statement for sure. What I hope instead is that we successively develop more and more powerful systems that we can all use in different ways that get integrated into our daily lives, into the economy, and become an amplifier of human will, but not this autonomous system that is
the
you know,
single controller,
thing.
essentially God.
Really don't want that.
What?
how bad is the completely unrestricted model? So how much do you understand about that? You know, there's been a lot of discussion about free speech absolutism.
Yeah.
How much if that's applied to an AI system.
You know, we've talked about putting out the base model, at least for researchers or something, but it's not very easy to use. Everyone's like, give me the base model. And again, we might do that. I think what people mostly want is they want a model that has been RLHF'd.
Scientific progress we're going to see. I'm a big believer that like real sustainable improvements in quality of life come from scientific and technological progress. And I think we're going to have a lot more of that. So there are all the obvious benefits. And, you know, like, I think it'd be good to end poverty. Like, maybe you think we should stop a technology that can do that. I personally don't. But we got to manage through the risk to get there.
The biggest issue I see with so-called AI experts is that they think they know more than they do. And they think they're smarter than they actually are. In general, we are all much less smart, dumber than we think we are, by a lot. So this tends to plague smart people. They just can't. They define themselves by their intelligence, and they don't like the idea that a machine could be way smarter than them. So they discount the idea, which is fundamentally flawed. That's the wishful thinking situation. I'm really quite close to, I'm very close to the cutting edge in AI, and it scares the hell out of me. It's capable of vastly more than almost anyone knows, and the rate of improvement is exponential.
Building multi-step applications and AI workflows shouldn't mean writing custom, complex code. Developers often spend too much time tracking progress, writing error handling logic, and managing retries instead of focusing on their innovation. AWS Lambda Durable Functions simplifies all of this. Write code using your programming language and IDE, while Durable Functions provides built-in patterns to manage progress and error handling. Build multi-step applications and AI workflows faster with Lambda Durable Functions without having to write complex logic or manage additional
Creator, that keep it fresh. Creator, that keep it fresh, yo. Keep it fresh, yo. Creator, that keep it fresh, yo. Touch is mad, the band sure.
Hey, what's up, Dak? Can you hear me? Let me get a sound check, Playboy.
Yeah, what up, man?
Hey, what's up, man? All right, back at it again another Thursday. Say what's up to the chat, the replay gang, man. Let's just get started. I ain't gonna hold you too long, Playboy.
Hey, what up, chat? Everybody that's on, man. Welcome on to the show, man.
Oh yeah, you know, and I talked to you before, like Jay Remo, Surge. If you talk to them, man, they could show up with you on a Thursday. We could turn this into a Theo University panel reviewing tech stuff. It'd actually be pretty dope.
Yeah, I gotta get back with them on that. I'll talk to them about it this weekend and see where everyone's schedules align and see what we can do.
Yeah, this is your Thursday spot, and I got Theo locked in. It's looking like on the Sunday spot because we did one this Sunday. But yeah. Before we get into it, we're gonna do a little bit more 𝐶𝐿. This is him. This is 𝐶𝐿 at talking AI, DevOps, Kubernetes, and he's with JetBrains. This is like a bigger tech podcast. And like I said, I just think it's good to watch 𝐶𝐿 drop knowledge, so brothers get used to seeing. Because he's in his, I think he just turned 40. He's 41 or 42. The guy's relatively young, highly accomplished. Basically doing a lot of the stuff that, like I said, we're using Kubernetes. He's the one that helped develop the entire Kubernetes project. So it's kind of like a big deal. You know what I'm saying? But You were telling me prior to getting on here, you were prepping all week for a potential presentation, et cetera, without giving away any details or critical details. What's the haps on that?
So this is for an architect role. Its focus is primarily with the machine learning life cycles and end to end. So designing different solutions based on the business and use case for a number of clients. So, but it's an entire data team. So data focused, data driven team. So you work with a team of data scientists, machine learning engineers, DevOps engineers, security, compliance folks. But essentially, the position is mainly architect focused. So it's going to be a lot focused on, the not just one little tree. You're talking about the forest in the tree. So the entire ecosystem for the machine learning platform.
All right, bet. I got the wrong joint up there. I had the wrong banner up there. I had the news desk one. All right, cool. Let's jump into this Kelsey. Let me add it to the stage real quick. Is my volume turned up? Yes, it is. So I'm gonna let's do this one. Hold on, because they have it broken. They have it timestamp. This one's cloud repatriation and hybrid strategies. You and I talked about hybrid strategies a lot as we were prepping for the helping me prep for the SAA. So let's play this segment.
Onto on-prem hardware. Have you seen this so far?
Yeah, I've seen it. I mean, I think 36 Signals was a good example. They went through every major cloud provider. So these are the company behind Rails. So very strong.
Hold on, let me run that back so you can hear the whole question.
Yeah, so you already mentioned that like Linux systemization skills are very important, and that we're seeing that platform engineers should create this API between the needs of the company and the hardware that's actually running it. A trend that we've heard about recently is about a lot of companies rethinking their cloud strategy and thinking more and more about repatriating onto on-prem hardware. Have you seen this so far?
Yeah, I've seen it. I mean, I think 36 Signals was a good example. They went through every major cloud provider. So these are the company behind Rails. So very strong engineering team, so much so that they've codified their way of building web applications and called it Ruby on Rails. And it became a framework for a lot of people trying to build three-tier architectures, 15, 20 years ago. And so the same group of people also bought into the cloud, right? They were a GCP customer at some point, Amazon, Microsoft Azure. And the challenge with that is the cloud isn't for everybody. And like a talented team like that, they can probably make any platform work. But in their world, they were able to benefit from their expertise and they can run it themselves. But I think what most people have struggled with was a concept of believing that you could rub cloud on your mess and it will somehow be better. And so what some people did is they didn't change anything. They still leave everything on. They still provision machines that are way too big because no one either has the tools or the skill set to actually do real performance analysis to figure out how much memory CPU do you actually need. So what they ended up doing was just lifting and shifting everything into the cloud. The problem with that, there's like a 2 to 3x premium to run in the cloud. It is a premium offering over buying a bunch of servers and running it yourself. So for those people, it was a huge penalty for their old behavior. And so after about 5 years of doing this, a lot of people are scratching their head and said, oh, we were not willing to change our operational model and we can't afford this tax. And on a positive note, a lot of hardware has gotten really fast and really big and the prices have come down in some areas. And also the cloud has evolved. We went from proprietary systems like EC2 and S3 to open services like Kubernetes and Prometheus. So you finally actually have a chance to get that cloud-like API on-prem. So I'm not surprised people are trying it.
All right, hold on.
Talking about technologies that were very...
Hold on. That was an excellent answer. And I picked this one in particular because even what he's saying, this is SAA level use case stuff, and Prometheus, Kubernetes, these are all tools we're learning to use in Theo's. As a matter of fact, I might actually use the same question on Theo's session. But what say you, Dak? What do you think about that?
This is, I mean, this is what I've heard from other people I know that in the industry, people that are at a director, CIO, CTO level. And the thing about it is that the price for storage and compute, like the physical storage, has dropped, and makes it's a lot more cost effective to having it in an on-premises system. When you have the physical infrastructure, you have a higher throughput. You have more control over the actual server. Think about with cloud, when he talks about the cloud utilization. Some people at the time when it started, well, actually a lot of people, let me correct myself, a lot of people were hyped about the cloud. This was like 15 years ago. Cloud was like where AI is right now. There was a lot of hype. There's a lot of push where people thought it was the turnkey solution for everything. And so, and the part that always people fail to read is the fine print, the details that goes behind that. And a lot of the rates that they charge just for to use the services on this particular cloud provider are not cheap, and then there are a hefty premium. And so what you had was, again, one of the cloud migration, you have migration planning. And so what he was talking about is like during that migration planning, you have to go through the business requirements, what does the stakeholders need, and then you have the technical requirements to try to get something that's similar technical specs that you normally would have run in a data center, but on the cloud. But you see, in the cloud, cloud computing is virtualized environment. The servers that have are real, but you're actually renting out. You're renting out virtual servers, virtual containers. It's almost like you're going to Netflix. You have a subscription model. You go in, you don't own the hardware. And so you're leasing that for a certain time frame. And if you put a lot of your infrastructure, a lot of your applications on and just migrate them over directly, you're allowing within that agreement that particular cloud is going to manage all of that technology. They're going to do all of the stuff behind the scenes when it comes to the debugging of those particular services. Whereas when you had it on the data center, you have full control from end to end. You own, you have sovereignty over your technology. But the moment that you give it to the cloud, certain things become lost and they have that control. And so then it becomes more of a cost and a security issue. So now you have companies, which what Kelsey's talking about is repatriating. They're scaling back on what they're using the cloud for because they realize, okay, one, they want more control. They don't want to put everything into the cloud. Certain things cloud does are advantageous for, especially when it comes to, like performing analytics and artificial intelligence, machine learning. But a lot of things they want to keep in-house, and you have, and you just have a greater control over how to fix those things, and you just have more sovereignty. And I think this is what he's talking about. There's been more of a push in the industry towards sovereignty, like a sovereign cloud that is independent of the major clouds. So hence data centers. You have data centers that are like private, that are specifically private to a particular enterprise, and it is a cloud, but it's a smaller cloud, and they have full, they have ownership of everything, and they have a better deal, and it's a lot less costly. So that's kind of what's going on. I mean, going forward, I mean, there's it's not so much full repatriation. It's more like it's multi-cloud. There's the public cloud that we talk about, like AWS, Google, Azure. There are private clouds. These private clouds are more boutique. Say, like you want to have like a specific AI cloud, like CoreWeave, that does all the work. You can work within that environment, and then again, there's the data center. So it's just made it more complex than what they thought it was going to be. It's not just it's a one turnkey solution. There's a lot of planning. There's a lot of things you have to pull together to get it to work, but it's going to be multi-tenant, multifaceted.
All right, cool. No, I think you're spot on. When I when I heard him answer the question when I was prepping for the show, like I said, it reminded me we've had conversations like that. You know, when you were explaining to me the hybrid models and why you don't want to have one single point of failure, and then why a single cloud solution, a monolith solution, is based on the case studies and the requirements from the stakeholders may not always be the best idea.
Yeah, it really is driven by the business. At the end of the day, it goes back, how does this solution bring back the most value to that particular business? I mean, some businesses, let's say if it's like a small business, and they could get by with just having it in the cloud, but even there, they still need to have it eliminate a point of failure. They need to have at least multiple availability zones, or at least in another region. If they have a global, if it's a global a small business, maybe they need another region. They need to remove those single points of failure, and those are just things that people forget. You know, you have to have some kind of contingency planning, you know, for disaster recovery and just backup.
Disaster recovery, right?
Yeah.
Well, maybe not directly, but remember there was that recent huge AWS outage that shut a lot of services down. I think we were.
Yeah, I mean, yeah, that's a clear example of that. I mean, the thing is that when you have larger like firms that rely solely on one particular provider, they run at the risk of losing a lot of revenue. They bleed money when that particular cloud is out, even if it's out for like maybe an hour, 2 hours. That's a lot of business, that transactions that go down. And so one of the things is that at the time when people go through what's called transformation technology or digital transformation, they're going in and they're trying to transfer, getting to a more digitized environment, not just on premises. Now they're in the cloud, and they'll have someone in that's a vendor for that particular provider, or maybe it's a consultancy that is also kind of partnered with, say, AWS or Azure or Google, and they get what's called vendor lock-in. So they'll show them a demo, and kind of like, show them demo of the technology that they have. And they just go ahead and not think clearly, like, okay, look, we would like to use a service. However, we would like to, have multiple. You're not the only one that we're going with. And so it's this delicate dance where, like, you have to go through the process of understanding what your business needs are before getting into that conversation with that vendor. And otherwise, you end up getting the bad end of it. You end up getting a deal that doesn't work for you, and it favors the cloud. Meaning, yes, AWS was down, but they were still making money. But all these other companies that relied on AWS, they lost a lot of money.
They lost a lot of money, right? Yeah, so the cloud provider was still making money while they recovered from
It's just like in the music industry when you have these 360 contracts, and then these artists will be like, homeless, and the recording company that's got all rights of all their music, their materials, and they're still making money off of that. It's very similar to that. It's like if you don't do your due diligence of knowing how to like go into that meeting and vet these people, then you're going to end up getting, the shit in the stick, so to speak,
All right, perfect. All right, let's switch gears real quick. I talked to you before, so I watched Tech with Solomon a lot. Less now, but when I was like first gonna buckle down with cloud and everything, and then I used to watch Tech with Solomon a lot. I like the way he explains things. He's got a very direct, be able to explain it to you in like layman's terms approach to things. But you and I have talked about this also. After the SAA, just deciding on what specialty you want to go into and being able to focus down. So this one, it's him, and I thought it's useful. Him, cloud engineer versus cloud architect. Which should you choose? And our conversations, where you were helping me study for the SAA, has me leaning more toward architect. But I wanted to go through this. I think it's good. And you give me your feedback on his take on these. Let me
Yeah.
add that. Let me add that to the stage real quick. All right, bang, let's go. Let me turn that up.
For anyone looking to break into the industry. And if you're considering a career in the cloud, then you've probably found yourself stuck between these two different paths, cloud engineer or cloud architect. The question is, which one should you choose? And is the conventional wisdom about these career paths actually setting you up for failure? I'm Suleiman. I've worked in tech for a decade and I run my own cloud security consultancy. Now, through my academy, I've helped more than 500 students learn cloud and AI with my first principles blueprint for engineers. I've personally worked in both of these roles. So in this video, I'll reveal what they involve, the skills that you need, and the salaries that you can expect. Because by the end of this video, you'll know exactly which path aligns best with your own personal goals. Now, before we dive deep, I need to clarify something. There's often confusion about what these titles actually mean. Cloud engineers are hands-on implementers. They're actually building and deploying cloud infrastructure. Cloud architects focus more on the design side of things. They're architecting the systems that cloud engineers will then go and deploy. Now, you may have heard of a solutions architect as well. They focus more on the high-level business strategy. In terms of career progression, it typically looks like this. You go from cloud engineer to senior cloud engineer to cloud architect, and then finally, you go to solutions architect. Now that we understand the landscape, let's dive into what these two roles actually involve. Cloud engineers are very much hands-on implementers who build and maintain cloud infrastructure. When Netflix needs to handle millions of users streaming simultaneously, cloud engineers will build the auto-scaling infrastructure that makes that possible. When a startup needs to deploy their applications globally, cloud engineers will configure the networking, the security, the compute resources to make all of this happen. Now, as a cloud engineer, a typical day can involve things like this: debugging network issues between services. So when different parts of an application can't talk to each other properly, you figure out what's blocking the communication and then you fix it. Maybe you spend some time optimizing cloud costs by right-sizing instances, making sure the company that you're working for isn't paying for more computing power than they actually need. Or you'll be automating deployment processes that were previously done manually, which is setting up CI/CD pipelines so that when developers finish coding some features, their work can automatically get pushed to production instead of someone having to do this by hand each time. So you're basically saving time. Now, as you can tell, it requires a deep technical skill set, particularly in one cloud platform. Now, I recommend AWS because it's the industry leader. So you'll need to master the core services: EC2, S3, VPC, IAM, along with infrastructure as code tools like Terraform or CloudFormation. You also need strong scripting abilities in Python and Bash, which are essential. Plus, you need experience with CI/CD tools like Jenkins or GitHub Actions. Now, career-wise, cloud engineers typically start earning around $100,000 a year. And as you start to gain experience, you can comfortably earn over $200,000. But what happens when you want to move beyond just implementing solutions to actually designing them? And that's
All right, what do you think so far?
I think it's, for what it's worth, he gives kind of a good layover as far as like what a blueprint for if you're going to go into the cloud and start with. AWS is kind of like, the standard. It is the most used cloud, one of the most used. I have one contention though. So you have people who are called cloud solutions architects, for example, and you have cloud architects and solutions architects. The higher up you get, the name of the roles don't matter as much. And it actually, being technical, having the technical knowledge matters. For a cloud engineer, it's very much needed. You need to know you need to be really like deep technical knowledge across a plethora of areas: infrastructure as code, scripting, doing the DevOps, creating the actual, staging for those environments. Once you get to architect, there are levels to the architect, in that solutions architect is kind of bottom tier. Then you have what are called principal or senior. You have a senior architect. Then there's a principal, and then above the principal is the enterprise architect. And the enterprise architect handles a lot with executive decision making, policy that affects the entire company. It's not so much as an engineer you have to focus on developing and supporting this particular application or platform. When you're as an architect, you're affecting the entire company's transformation of technology. I mean, like, it's not just the IT department, it's the entire company. And so you have a lot of focus on business acumen, executive presence. The technology is there, but it kind of becomes less of an important thing. It's still important, but what becomes more important is understanding all the key members of the company, knowing what their processes within these departments and the people and their pain points. And then you assemble this team where you have the lead, let's say you're a senior cloud engineer, you have the division of architects who specialize in certain domains. So you're going to have an architect that's going to be security focused, networking focused, data focused, and the technical architect is focused on all the platforming across the entire systems. And so all these people have to come together and assess what those requirements are and those pain points from the business, and strategize a policy and blueprint that's going to work for everybody, that's going to drive value back to the company. And that's something that will be about maybe 60 to 70% of what an architect does. And then 30 to 40% of that's you're gonna have to know the technology. But you have to understand the technology, you have to understand it deeply, but at a high level. Because when you're in that room giving presentations, discussing about what the plan is, you have to be able to discuss how it's relevant to those executives and those key stakeholders. So you got to you have to know how to communicate at their level, which comes back to the speech ops. So speech ops becomes much more important at the architect level, and especially when you're dealing it with business. You have to, it's communication. And so at a certain point, yes, they're a solutions architect, but it's not the highest role. Enterprise architect, whoever, and then even above that, it's going to be like your chief technology officer or your chief security officer, your chief information officer, chief operations officers. Those are going to be the tippy top of the food chain.
All right, excellent. All right, real quick. All right, let's do architects.
It's where cloud architects come into the picture. They operate at a completely different level to cloud engineers. While cloud engineers focus on implementation, architects focus on high-level system design and strategic technology decisions. For example, when a company like Airbnb needs to scale to handle millions of global users, cloud architects design how services will communicate, how data will flow between different systems, and how the platform will stay online even when individual components fail. When I was working as a cloud architect, my role completely changed overnight. Although I could build the actual infrastructure hands-on, that was no longer expected of me. In terms of a typical day in the life of a cloud architect, it involves meeting stakeholders to understand business requirements, sitting down and figuring out what problems that they need technology to solve, and what constraints that they're working with, because everyone is working under a set of constraints. You'll be creating system design documents, basically drawing blueprints that show how all the technical pieces will work together. You might be reviewing technical proposals from engineering teams and making decisions about technology standards. So choosing which tools and which approaches that the entire organization will use, ensuring that everything is working together smoothly towards a longer term strategy. Essentially, cloud architects focus on the big picture, which requires a skill set that goes beyond pure technical knowledge. Yes, you need deep understanding of cloud services and system design patterns, but you also need business acumen and the ability to make technical decisions that align with business objectives. Salary-wise, cloud architects typically start around $140,000 to $180,000, and experienced architects can earn anything between $200,000 to $300,000 at large companies. Now, here is something critical that many people don't understand about this career progression. You cannot become a cloud architect without first being a cloud engineer with hands-on implementation experience. Now,
what do you think so far?
I will say it depends. This last piece he mentioned about in terms of like being a cloud architect. Cloud architect essentially is really a project management position. If there are people who are architects, and yes, you have to have the understanding of the technology, but at the end of the day, you're doing this. This is like an executive role, and so a cloud engineer is not going to know about how to walk into a room and read people and know when to speak, how to communicate to a non-technical person. That's like saying if someone is a doctor, has to be a nurse to become a doctor. You have to be a pharmacist to become an MD. And in many cases, you don't need that. But I would say if you're a cloud engineer and you try to become an architect, then yes, you're going to need to. I think that would definitely make a lot of sense. If you already have the engineering background and you're trying to move into an architect position, there are still some skill gaps that you have there. And he addressed it. It's like, yes, at that point, the people don't care about how good you are at deploying Terraform code or pushing, like GitOps. They're looking at how do you come in and listen and lean in to hear what their needs are, and then work together with other people across different domains to drive the solution, to drive the logical architecture, which drives the entire implementation. And prior to even the logical architecture, which is completely high level, technology agnostic, you've got to understand, how do I even know that a certain technology is even required based on the business use case to drive the use case that then drives the logical architecture? So these things are it is a very complex process. And just like an engineer, if you're an engineer, you will know that you don't have access to everything that you do within your project. You're given role-based access, based upon, identity and access management. Architect is the same way. While the architect is overseeing everything, he puts the trust, goes into the engineers and those who are responsible for implementing those solutions. So his architecture is imperative, and it's the focal point that drives everything. And so something happens within that particular project, and it's good or bad, it all falls back to the architects or architect on that project. They take the fame and they take the blame. And so it goes right back to them. Whereas the engineer, something happens, all right, you always get on to another project, you debug it, document, troubleshoot, but it all falls back on the architect at the end of the day.
Rogue Pill says, sounds like a comprehensive role that requires a larger understanding, familiarity with the environment and technology needed to be implemented.
Yes, it does. But it also comes with, you have to have a certain mindset, frame mindset, where you have to lean from other people. Okay, you can't do it all as an engineer, but as an architect, you can't do it all. So you have to lean onto your engineers. You have to lean onto the security people. You have to have them all in that meeting, because it takes teamwork to make the dream work. And in order to make the blueprint work right, you got to bring these people in, because at the end of the day, security and the network is essential to driving from the business ideation to driving out the full scale product. So yeah, it's a team effort.
All right, bet. Let's hold on. Let's bring the video back and let's some more play.
I know there might be some people on YouTube that tell you they were a cloud architect or they are looking to become an architect first. But when you see things like this and you hear things like this, you have to think logically so it makes sense. How can you design solutions if you've never implemented anything yourself? How can you understand the practical constraints and challenges if you've only worked with theoretical concepts? When I was working as a cloud architect, my background as a cloud engineer was invaluable. I could spot potential problems in architectural designs because I had debugged similar issues in production. I understand which solutions look good on paper, but which one would be nightmares to maintain in production environments and how it would work operationally. Most importantly, when I presented architectural designs to engineering teams, I had the credibility because they knew I'd actually built and maintained similar systems. You can't get hired as a cloud architect without significant hands-on experience. So if you're just starting out, the path seems very clear. You want to begin as a cloud engineer and you want to build deep technical expertise before moving to more senior roles like a cloud architect. So don't fall for it. There's no such thing as a junior cloud architect. It doesn't exist in the real world, okay? It just doesn't, right? No one is hiring real junior architects and assigning them to clients so they can make big strategic decisions. And trust me, I know I've worked with many organizations from Fortune 500 to startups to government agencies. But anyway, this traditional linear progression is being disrupted by something most people haven't even noticed yet, because there's something happening in 2025 that's fundamentally changing these traditional career paths. Now, the boundaries between a cloud engineer and a cloud architect are slowly dissolving. And a big driving factor of this is AI. Companies are realizing that engineers can be way more efficient today and get more done with way less time. So naturally, they expect you to have a more well-rounded skill set. So this is creating opportunities for a specific type of engineer. Let me explain. When I look at the most successful people in tech today, Elon Musk, Jensen Huang, Sundar Pichai, Satya Nadella, these big-time CEOs, they all have one thing in common. They are all what I call technical leaders. They understand technology deeply enough to make strategic decisions, but they also understand business and implementation realities. Take Elon Musk as the perfect example. Now, whether you like him or not, before becoming the CEO of Tesla and SpaceX, he was hands-on engineering. At SpaceX, he taught himself rocket engineering and was personally involved in designing the Falcon 1 rocket. At Tesla, he understood both the software and the hardware engineering and the challenges of electric vehicles. This true engineering background is exactly why he can make strategic decisions that other CEOs simply cannot do. When SpaceX needed to reduce costs, he understood the technical constraints well enough to give specific engineering solutions like reusable rockets. These guys are no longer just visionaries. Long gone are the days where CEOs of big tech companies can just be business people. You need technical understanding and real implementation skills, which all of these leaders have in common. And I see a similar pattern emerging in cloud. The engineers who are absolutely crushing it in today's market aren't just pure cloud engineers or pure cloud architects. They are technical leaders who can operate effectively at both of these levels. These are people who can just sit in a boardroom and explain to executives why a particular architectural approach will save the company $2 million annually. And then they can just go back to their desk and actually build the solution that they've just proposed. They understand business requirements deeply enough to design the appropriate solutions, but they also have the technical skills to validate that their designs actually work in practice. And because of
That's similar to what you were saying. What say you?
I would say
Similar to a point you were making, at least.
it's similar around, I will say it's definitely what he's saying there. Okay, he is alluding to something, and this is what I was talking about, the technical architect, which is also maybe referred to as engineering architect. Now, while they will definitely, it's a much more senior position, they do make architectural decisions, but they still are responsible for deploying and implementing the actual technology. That position is there. What I will still like to give perspective on is that, yes, it's help if you have someone like an Elon Musk, for example, that has the engineering background, but he was a top engineer, and he was able to navigate through those channels and know how to translate what the engineers talk about, the nerdgasms, and know how to translate that upstream to business people. And that's something that takes time. Each one's going to have to make that assessment, those who choose to go that path in the leadership role. And I think one of the things that helps is that you have to make a transformative change within the company. It's not so much that you're the technical leader that has the engineering background, but you have executives, and it's no fault of their own in particular. Partially it is, partially isn't, where they don't necessarily know about how is this even like separating the hype from what's tangible and what works. And so a lot of that comes into training and development. So as an architect, one of the other roles that comes with being an architect is being someone that facilitates development within those teams, the engineers, the DevOps people, all those people that build implementation, that they get trained up and mentored so that they're not just kind of like going in the darkness and not knowing how to lead. They have that from the top down. And so that's one of the aspects of an architect is also rated by. They're not just rated by what they bring back to the business, but they also are rated by what are their understandings of possible or new technologies that would be impactful and helpful to the implementation. So part of that goes into to an architect, not so much the designing. It's not just designing a platform. It's also about designing training and development to get the people who are implementing it, getting them skilled up. That's one of the roles that is critical, is that people understand from the bottom up that they're being backed and supported. That's why I say that the architect takes the fame and the blame. So they gotta make sure that their people are also rising up. And then when it comes to the business, you need still at the end of the day, architect, even the engineer has to understand how to communicate. And as long as there's things put in place for an engineer to understand business acumen and how to present, I think that'll definitely help along the way. But I disagree with the part where he says that engineer and architect roles kind of like they're almost the same. They're not the same. AI cannot even implement AI architecture, like actual, not like application architecture, but architecture as far as enterprise for the entire company. It does not have that capability. You still have to go through human feedback. You have to go through these key stakeholders, and each one is going to be very different. That's the only thing I'll give pushback on is on that part when he says like those particular roles kind of like erode on responsibilities. There are definitely differences. I'll just leave it there.
All right, excellent. And that's why I played. That's why I wanted to go over that segment. I was like, okay, this will be good fodder. All right, excellent. All right, we're at the 49-minute mark. Let's just this is 6 minutes. Let's do what's your architecture and get up out of here. This one is let me see. Prudential Financial delivering data velocity, and we'll see the service, the Amazon services that they end up using. All right, let's go, and they'll give us a schematic.
Hi, I'm Josh from AWS. I'm Shihaz Famanjur from Prudential, and this is my architecture.
So Shihaz, Prudential is a large financial.
Okay, yeah, they're using glue and step functions.
financial institution. And I imagine that with that territory comes lots of challenges around data, amounts of data and different types of data and how to deal with that. Can you tell us a little bit more about those challenges and have you dealt with them in this architecture?
Prudential, like any other modern enterprise, needs to create its data products faster and cheaper. And this architecture delivers on the promise of increased product creation velocity at lower cost.
So I'm looking at here at this user coming into this marketplace. Can you tell us about that flow?
All right, let's stop it right there. Let me remove the chat comments too. You want to look at that schematic?
Yeah, I see. I just said let it play all the way through. I just let it play all the way through. Yeah.
All right.
And why you chose this model?
The primary purpose of the marketplace is to create a browser-based experience where the user can discover, understand, and access data. This is the purpose of the marketplace application. It simplifies the entire data community's experience with the data estate. And this is done through a series of automations that move data across the different zones that you're seeing on the screen.
So it comes in here. I see some kind of manifest or document file here, and then it's coming in through data sync. Can you tell us about that flow and specifically why you chose data sync here, or if there are other services?
Sure. The manifest contains instructions for the kind of data the user would like to move across the data estate. For example, the data could exist in file systems, databases, APIs, streams, any number of different source systems in the enterprise. Data sync is an example of an AWS service that we use to bring data from file systems. There are other services that we currently do not represent on this slide, including Glue, which is connected to JDBC sources, Kinesis, which is connected to streaming sources, DMS, which is connected to databases, so on, sources, and so on. But the manifest-driven experience abstracts the user from the nature of the source and the transport and shipping involved in moving data across this particular estate.
It sounds like it's really adaptable and flexible to a bunch of different data types, which is what we were talking about earlier with all those different data types and you see in enterprises. So we have S3 and Redshift in the next phase here in this standardization. How does Glue Data Brew factor into that standardization story? And why do you have S3 and Redshift?
So the purpose of this application is to support multi-purpose usage of data. S3 represents a lake pattern of usage, which is connected to data science and machine learning. Redshift is connected to a house pattern of architecture, which is usually connected to business intelligence use cases. And Glue Data Brew is our transformation tool, which we use to dynamically create the automatic workflows to move data from the landing zone to a standard zone that represents the source in a time series manner. This layer is also extensible with other technologies such as vector databases as well as graph databases.
So looking at all these services, you talked about the data lakes and all these standardization and refinement steps. There's usually a lot of data engineers, human activity involved in this process, but you're looking to automate. How much of this is currently automated today?
You point to an important concept that addresses both velocity as well as lower cost. This portion of moving data from the source to the landing zone, which is step 1, and to the standardized zone, which is step 2, is fully automated. So no human being writes code anywhere at Prudential to do this. The subject of refinement of data, which is where business rules are written, this is where human engineers come into this picture. And now they spend most of their time in this space. Historically, they would have spent a significant portion of that 80% in moving the data across this estate.
Yeah, so now they can focus on what matters and add value here in the refinement stage. I want to move to lake formation in this governance step here. Lake formation, I imagine, is playing an important role in governing the rest of this workflow. Can you tell me more about how you're using it?
Sure. Now, one of the 3 things that the marketplace allows you to do is discover, find, and access. The access is where lake formation comes into this picture. Now, throughout this journey, what we've described is a shipping model and an organizational model for data that brings data to a usable form. Now comes access to this data, which is a security and a governance question. Lake formation is a service that we use to centrally secure access to S3 and Redshift. Now, the marketplace similarly delivers access through the manifest, which is an instruction, a request for access, which then goes through approval workflows. That is the purpose of using AWS Lake Formation here, to centrally govern all access privileges across this estate.
Yeah, what I like here is that the user can specify what they want to achieve and not necessarily how it's going to be achieved under the hood, right? You can automate that away, and you can have the lake formation manage the governance, and you can have these automation steps handle the standardization.
Yes. AWS services work very well under this abstraction layer of a marketplace application in order to orchestrate these flows minus the user having to know about them. That is correct.
And then lastly, we have this SageMaker and Athena consumer section here. Can you tell me a little bit about that?
This layer represents consumption models, which is both traditional as well as advanced analytics. Athena represents a SQL interface. SageMaker is a machine learning interface. You could introduce any third-party tools as well into this picture.
So this is a very extensible and flexible architecture.
All right, perfect. There we go. What say you?
This is, so you can go back to the initial architecture,
Gotcha.
initial picture. So that little pink grid, that little pink circle in each grid, those are step functions.
Okay, those are step functions. Okay.
So the step functions are generally they're like an orchestration. They help orchestrate multi-step processes. A Lambda function is an orchestration service, but it only can do things within up to 15 minutes of processing. When you have processes that take longer than 15 minutes, you have what are called step function workflows. So
Okay.
This is the flow diagram. This is a data flow diagram. And he's going from left to right. And so initially there's someone's buying something online or to make it a purchase. And he's talking about the manifest document. That's essentially a list of, okay, I want to do something and it requires access to that particular role. Well, in order for it to do that, it has to go through and verify and credential that person in order for them to actually have access. Now, part of data, in this data architecture, he alluded to was data governance. And the governance policy talks about a lot about that's on the business side. Like, okay, or who are the people that need access to this data? Who are they? What are they given? And what for? And so lake formation is baked into that, where you have a policy. Those business policies are baked into that lake formation, AWS lake formation. They put all of those policies in there. And again, like this setup is part of a company. So Prudential, they have employees, they have accounts. So they have to log in to get access. So all of that goes back to doing security, right? Data security, identity access management, federation.
Mm-hmm.
So the lake formation helps them federate that access from the manifest. Now the files in the database that's on the far left, those are things that are likely on premises, on-prem. So this is a hybrid connection. So part of that step is going to include some type of data migration. There's going to be a data migration process. And then there's going to be like something like a data sync. Data sync helps link in different types of data, whether it be a file storage or a database. And so, or API for that matter. All of those are there. That allows us to at least connect to those particular sources of data. That's that first part. The second workflow is where you're beginning to have all of that data that you have acquired, and now you're storing it into what's called a lake house. So, or a data lake. Let's just call it a data lake. It's because a data lake, an S3 is what you would consider as object storage. Object storage is kind of different from, say, like a table, a data table, or a database, a regular database. S3 can handle with semi-structured, unstructured data types. And so all of that data that's from the first workflow is now consumed into this S3 bucket. And it's called an S3 lake. So it's used, so people like data scientists, machine learning engineers, if they want to do any kind of work on that data, they can do it from that data lake from the S3. But it's just a pool. It's just a pool of just different data types. And they can get varying insights, those machine learning engineers, data professionals, data scientists. Now, again, the data in the data lake is pretty much in its raw state. It's in its raw state. It's like, it's at its raw state. It's like the raw feed. Then you have what is called like the transformation. So like you have ETL, extract, transform, and load. So Glue, AWS Glue does the transformation of that data that's in that S3 lake. So it's taking whatever that data that's in there, not all of it, but it's taking certain pieces of that data using the data brew. And data brew is essentially it's an orchestration. So it's orchestration layer of it's a transforming orchestration part. And so that's going to take a while. And what it's going to do is transform that data to be put in what's called a data warehouse. Now, the data warehouse is where you take essentially the product that you have. It's in like a stock room. Like everything has already been cleared through. This data warehouse. This warehouse is where, say, someone that's like who wants to do business intelligence work on it, they can access the data there, right? They can access it in Redshift. That's what Redshift is placed on.
Right.
So they're not going to have access to that lake. They're going to have access to, say, like maybe like Redshift. And so Redshift is where all of the transformed data that's going to be used for like the business is going to be placed there. Now that's all done within the step function. A process like that is going to take longer than 15 minutes. It may take hours, but that's where step function is for. It's just an orchestration layer.
Okay.
So yeah. All right. So the third piece that we have is the Glue and the S3. So what he was talking about is that all of the product data that they've extracted, that they have in the Redshift and
that's now useful for business intelligence, right?
Yes, and then they want to do any extra, like, extra transformation.
Right.
That's where the engineers come in, like the data engineers come in. They bring in the extra things that they may need to get from the business that's needed. They put that in that third workflow. And so whatever that's stored there, it's going to be stored in a particular S3 bucket. And that's going to be like the transformed data from the warehouse. So, and again, like, it's not all of it. It could be certain pieces of things, certain products they need to do fine tuning with. That's what that third piece is for. So it's for the fine tuning. Now, the last part is the governance, and that's the part that I was telling you about with the lake formation. The lake formation is what grants the manifest. That has all the policies, like how they're going to handle with the employees, who has access to what. Within based on that manifest, like who within the company has access to what particular parts, and to what degree. Do they need to just read the data? Do they need to just update the data? Like, let's say like HR, let's say it's an HR, right? They need to read and update the data. That's all they need. But some users may only need read access. They just need to view something. So that's what lake formation does. It all that data governance is all baked into there. You put all that policy in there. And then the Lambda function essentially is what orchestrates and drives like the process of, okay, I need to get access, grant access and to that based on that manifest. Now, that's all in that step function. That's the fourth, that's the fourth piece. Now the consumer is the one on the back end. Now the consumer wants to do any kind of reporting analytics. That's going to be with Athena. Now Athena is one, but you can use something like Power BI, Tableau, as a way to do like any kind of like data visualization and analytics. SageMaker comes in. That's kind of like the brain that behind like the driving like the machine learning, like capabilities based on the data, and all of that, and all that data that's went in there, is being consumed at that point for other purposes. So that's pretty much it, man. But like data architects it's a very thorough process. And when you have, it's just a lot of layers. It's kind of like security. When Theo goes over security, how you have to talk about identity and access management. One of the key focal points in doing data architecture is data governance. And so data governance is what drives who can access what and what they can access and for what purpose. And so before even designing this blueprint, you have to go through that policy first, that governance policy first, which sets all of this other stuff up. That's what makes it work. There has to be a delineation, so to speak. Just like, we talk about delineation and other aspects, there's definitely, you have to have delineation on who does what, who has what, and how much. Because what you end up, if you don't have that, you can have someone, infiltrate the system and take this information, and sell it, to maybe their competitors, or maybe hold it, like sell it out to the dark web. So those governing policies, just like in identity and access management, prevents that. It locks people out who shouldn't have it. And it only allows access to those who are explicitly defined to having that access.
All right, spot on. Great. All right. No guarantee says great content. Detroit 313 in the building.
All right.
Yeah. All right. We're at your 1 hour mark, man. I told you I wouldn't hold you any longer than that. Let's get you up out of here. Hold on. Let me switch over real quick. No. What did he have a question? He said quick question.
I wanted to. Yeah. So.
No guarantee said quick question. How do these technologies profit us as practitioners with the talk from Davos World Economic Forum? Good question, actually.
That's a good question. What you have to understand is that the type of skills that you're acquiring, especially like in Theo's class, this is something that is going to last past what's currently being discussed in Davos. One of the things is that Theo tells us at a certain point, it's asking us, what do we want to do? And he always reinforced to look within ourselves and what do we want to specialize in? That helps us pivot into areas that where we become specialists that will keep us recession proof. Security, he strives security, networking, data, all are like roles that will continue to go on to be demand. And I wouldn't like so you're in the right place. Like it's just gonna stay focused. If you're in Theo's class, do the work, get what you need to do, get the certain baseline certification, whether that be the Google Cloud Professional Architect, or if you're going to go for the SAA, get that. Then after that, and I would just say, like, focus more on, getting the skills right. Get your skills right, and those are skills that you are getting that are going to be in demand. I mean, here to come.
Yeah,
No
cloud.
matter how the market's going.
Yeah, and cloud's forecasting to be $1 trillion industry, bro.
Yeah, so you're on the right path. Just stay focused.
All right, 100%. All right, bro. We're at the 1 hour, 10-minute mark. I know I got to get you up out of here, man. Thanks for coming through Thursdays and doing this with me, man. This is believe it or not, I think we're doing a public service with the sit down with you. Like I said, you were my accountability partner for testing for the SAA. So I figured, man, we should probably just do the study sessions we used to do, just do them in public. I mean, except I sneak in what's your architecture at the end, so I get my little piece of system design that we would normally do. I don't know if you peeped that, right?
Yeah. Oh yeah, man. Oh yeah.
I don't know if you peeped that. Yeah.
Yeah,
But
you
no,
got a little extra in there. Oh yeah.
Yeah. So I get like a little piece of study in. But no, that's tight. No, but I think these are going to do real well in the Sunday subjects with Theo. We need it anyway, especially having people who have been successful in the boot camps. All right, man. I'm not going to hold you any longer, man. Anything you want to say to the chat, the replay game? Because I don't know if you know, I put these in rotation. So like the one we did last week, that's played like 4 or 5 times on the channel already.
Yeah. I just want to all those who are on live, man, shout out to y'all for showing up, and to those who are watching on the replay. This is I come from having like machismo from Theo's group, and this is something that we will do regularly, review different tech influencers and give you the straight no chaser as far as like what you got to do, and just keep it on the level, just like we do.
All right, excellent. Yo, man, like I said, man, appreciate you. I know you got to get back to work. I'll see you next week, man. On that note, guys, we're out of here. Here's the AWS product and services drop.
Building multi-step applications and AI workflows shouldn't mean writing custom complex code. Developers often spend too much time tracking progress, writing error handling logic, and managing retries instead of focusing on their innovation. AWS Lambda Durable Functions simplifies all of this. Write code using your programming language and IDE, while Durable Functions provides built-in patterns to manage progress and error handling. Build multi-step applications and AI workflows faster with Lambda Durable Functions without having to write complex logic or manage additional infrastructure. Get started today.
Creator, that keep it fresh, yo. Creator, that keep it fresh, yo. Keep it fresh, yo. Creator, that keep it fresh, yo. Touch is mad, the band, Creator, that keep it fresh, yo. Creator, that keep it fresh, yo. Creator, that keep it fresh. yo. Creator, keep it fresh, yo. Touch is mad, the band